Good afternoon, everyone tuning in to another version of the National Museum of Industrial History's virtual museum. Today we're talking about a very interesting topic, which if you've been in the museum, you've seen our overhead crane as soon as you walk in the museum. It's pretty visually striking and ties in nicely with the talk that we had yesterday about machines from Milwaukee. So if you didn't catch that talk, go back and watch that. It'll give you some nice context for this crane. If you're watching at home, you can check out some other of our topics that we're going to be covering in the future, including a virtual tour through a massive and very impressive steam engine in Phillipsburg, New Jersey. That's going to be taking place on Tuesday. And we have a couple other programs that we're going to be scheduling out towards the end of the month. So we encourage you to stay tuned to our Facebook page here. And also check out our website at NMIH.org. And if you're watching at home or on Facebook or YouTube or anything, or a website later on, you're watching this program for free. If you're able to help out right now, there's a couple very easy ways that you can do so. We're working very hard behind the scenes to create these programs for you, and we're working very hard to save artifacts while we're still closed. And you can go to our website at NMIH.org. We're going to post a link down below as well. A couple of ways that you can help are donating to the museum, just giving a general donation. You can buy a museum membership, and we actually just introduced a new program where any membership retroactive to March 14th that is purchased at the museum, we're going to be providing a healthcare worker with a free family membership to the museum from St. Luke's University Health Network. So we're very happy to be able to not only give out free content, but also provide to our healthcare workers so we can keep our community safe during the pandemic. Without further ado, I'm going to turn things over to Mike Piersa. He's the NMIH historian, and he's going to lead you on a kind of a condensed version of the talks that we've been doing about our overhead crane today. And we encourage you, if you have any questions, to ask them in the comments down below, and we'll try to answer them at the end of the presentation. Thanks, Mike.
Thank you for having me, Glenn. I'm going to begin the screen share here. So we should see this coming up in just a moment. We should be popping up real quick now. So this talk is about the Pauling and Harshberger overhead crane in the museum. Hopefully, those of you watching this talk got a chance to listen to Tom's presentation yesterday, where he gave the history of Pauling and Harshberger. He did a fantastic job, so I'm not going to go back and review what he did. I think his presentation stands on its own and is really excellent. So what I want to do today is focus on the crane that's at the museum, and start doing that by giving you guys some context about how this crane really fits into the rest of the plant in Bethlehem. So when you look at the museum and you walk in there and really take a look at this crane, it almost seems to be a natural part of the building. But there were many different varieties of cranes in Bethlehem. So I want to do a little quick tour just to see what other types of cranes there are. And then this one will make more sense about why it's in this particular location and why it does what it does. So probably the simplest and smallest cranes you're going to find at the Bethlehem plant are these little tram rails or monorails. They have one beam and they have a little trolley on top with they look like railroad wheels, but inverted. So the flange is on the outside, and they have a hoist that they draw along. The hoist could be a chain hoist powered by hand, or in this case, it's actually powered by compressed air. So when you start thinking about how these hoisting mechanisms are operated, we want to keep in mind that there were a variety of different ways of doing this in the 19th century. You had compressed air, you had hydraulics, you had steam, and steam could be a variety of different manners. It could be actually literally putting a steam boiler and engine on top of the crane, or it could be having a steam engine drive a pulley and then a line shaft, like you see on display inside the museum, which is just a long shaft of iron or steel going down the length of the building. And that transmits power via pulleys to an overhead crane, which then transfers energy into a hoisting mechanism. So when you look at things like that, you have a tremendous loss of energy just in the friction of the line shafting system. when you actually put a boiler and engine on top of a crane, you have to figure out how do you get fuel and water to it, how do you get ash away from the coal. You have to worry about steam and oil dripping down on the shop. Then what do you do with the exhaust steam? It can really turn into a mess quite quickly. So that's why in the late 19th century, when overhead cranes were developed, they really came on the scene very quickly because they offered so many advantages. They could do everything those steam cranes could do, but they could do it very cleanly and very efficiently. Even compared to the air-powered cranes like this, you don't want to be dragging an air hose around the shop. This is okay in this particular manner because the hoist only travels a relatively short distance. But in some cases at Bethlehem Steel, you could have cranes that would be going up and down a building for 1,000 feet. This is the crane that's in our neighboring building, the carpenter shop. It's a 3-ton hoist, electrically powered, but it's still a very, very simple device. Runs on one track, so it can go forwards and backwards, but not side to side. You can see its electrical components are there on the trolley that actually trails the main hoist, kind of like a train. It goes back and forth all as one unit. And you'll notice that there's no way for the operator to get up there and control it. In some instances, there would actually be a little cab attached even to these monorail operations that the crane operator would ride along with it. But in this case, in the case of many modern cranes, you have what they call the pendant control. So you'll see a series of buttons here. You have your power on button and your reset. Then we'll zoom in. You have your trolley button, which moves the crane backwards and forwards, and your hoist moving it up and down. On a larger crane like you have at the museum, you'd have an additional set of buttons to move the bridge up and down the length of the building. These types of controllers are still in use today. They're very popular. The other way of controlling cranes today is remote control. You can actually take an old crane like ours and rig up a remote control pack, like an enhanced version of the same basic technology you find like for remote control airplanes, trucks, toys, things like that. And you can operate these overhead cranes with it. It's a very safe and a very effective way of working them. So as you look at the evolution of cranes in Bethlehem, one of the most fascinating ones is this machine from the late 1880s in the High House. This is a crane block. We'll be looking at a diagram of a typical overhead crane in a few minutes to see how this all works. But your lower block has your wire ropes going up to the top block and hoisting mechanism. The more wire ropes you have there, the more the force is amplified. This is actually a 100-ton crane. What makes it unique is not the capacity, because Bethlehem Steel had much heavier ones, but the way it was actually driven. This would pick up large battleship guns, and in the late 1880s, before you had the wide flange beam, and you were really limited to riveted construction, I-beams, and smaller or more traditional structural members like that, you really didn't want to have a whole lot of weight up on that bridge. So what they did here was they put the hoist up there, but the actual, sorry, not the hoist, the pulleys up there, but the actual hoist and motors were placed on ground level. So you can see the 100-ton electric hoist down here, the cable rising up. And then if you drive by the High House on the Mincy Trail Bridge, you can see a big pulley sticking out of the building near the top on the north side. And that pulley actually takes the wire rope down to this hoist, which controls the operation of that crane far overhead. So this is a rather complicated system, but it was about the best they could do back in the 1880s, and of course upgraded over time with electric power. But by the time the 19th century rolled around, it became much more, end of the 19th century rolled around, it became much more practical to put all of this hoisting machinery up on the crane itself. This is a view of just to show what this setup looked like. When you can see it in drawing form, sometimes it's easier to understand. You have your 100-ton hoist down at the lower right, cable going up to the pulley, which it's actually scaled down here. We could do the math, 39 feet plus 69 feet plus another, it looks like 16 feet, and that gives you the height of the crane. So if you had to reinforce that building enough to have that hoist up there, you're looking at a bunch of extra work, which was worth it in later years for other facilities, but not in the late 1880s when they were building this. So it's a fairly unique mechanism to survive. And you can see it actually lifting up the battleship guns one at a time as it would put them into the furnaces, assembling pit, or quenching tanks. So as we move along, we'll see some of the other types of cranes used in the plant. When I talked before about how the number of ropes going up and down indicates how much leverage you're able to get on that load, you can see this is probably one of, if not the heaviest crane in the plant. I was told it was eventually upgraded to 450 tons, and this was using electric furnace melt shop. It's a very, very short run. I think it's just the hoist moving in a trolley fashion across what we would traditionally call a bridge, but it's still an overhead crane, and it can pick up tremendous loads. Other more unique cranes included one in Central Tool, which actually has the operator's cab on a small platform above the ground. I'm going to guess maybe 6-8 feet high, just eyeballing it. And then the overhead crane is remotely controlled above him. It's a fascinating way of doing this that goes to show there, even though this was a standard product, there are really many ways of adapting it to the plant. Now, if many people are used to driving by on 3rd Street, 4th Street, you can see it from there too, is the ore bridge. That's actually a type of overhead crane. It's not an overhead traveling crane like you would see in the buildings where the building columns support the crane. Instead, this is more like a gantry design where it has its own legs and then wheels that ride on slab poured piers in a yard that would allow it to travel back and forth. But that's only a 15-ton capacity crane, but it's spanned over 500 feet long. And again, there were 2 of these cranes at the peak when they were in the middle of replacing them. There were photographs showing up to 4 of them at one time. And these were instrumental in moving ore to the ore yard where it was stockpiled when you had Great Lakes transportation unavailable during the winter months. There are also ingot stripper cranes like this one. So you have a traditional overhead crane design, but instead of a hook coming down, you had these tongs that would lift ingots out, and they would put them into the soaking pits, as you see here, or retrieve them from the pits, and then take them to the rolling mills. And the whole rolling operation is really a separate talk in itself. But what I want to stress is that you had a whole variety of different cranes and different attachments. You had electromagnets in other parts of the plant for picking up scrap metal. And even the larger cranes that picked up the molten iron, like you see here, going into an open hearth furnace, they had what they called auxiliary hooks. So if you think about how you're going to pick up your load of molten iron, you can go straight up with it with a traditional crane like we have at the museum. But if you want to make that load tip and par out, you have to actually have a whole separate hoist and hook assembly on that same crane. So some of the larger cranes actually had 2 hoists built onto that trolley up in the air. That way you could pick up one load and then raise or lower the back end of it to tip it or level it off, as you see here with them pouring molten iron. So now we're getting into the type of crane that we have at the museum. This is a sister crane also built by Pauling and Harshberger, located, I believe, in Central Tool. It's a 7.5-ton crane. You can see that, again, this was a very engineered product. The design here has beams, but they have the circles cut into them to lower the weight. And you can see that this was actually used on the top floor of the building because there is a hatch that the crane would pick up its load through the lower floors from. This one has a pendant control. Some of the cranes were so small that if you had to have an operator's cab on them, that would interfere with their the places that they could actually go. Plus, it made a lot of sense to have that pendant control right by the hook where you could get a better view of it. Another crane from that building is a traditional fish billy design. This is kind of like what our crane looks like. It was a way of adding extra strength to the crane. At this point in the building, down at ground level, you could have extra material on the crane and it wasn't going to break your budget. This is also a good way of seeing how the system was actually set up. This is all integral to the building column. So these cranes generally couldn't be taken from one place to another. They were custom built, whatever spot they were going into. That being said, there were several buildings that were basically twins of each other. So their column spacing was similar. So theoretically, you could interchange cranes. And cranes did actually move around. I know there's a crane at Stilton that was used at the Bethlehem plant. So it does happen occasionally, but by and large, they're designed for the space that they're going to be used inside of. So when you look at the crane, I've been talking about the fish belly design. That's the design of the girder. Those are the long beams that act like bridges between the two gray parts. The gray pieces you see there are the runway beams. Those actually have little railroad tracks on them, one rail on each beam. So the thing acts like a giant railroad car. It has wheels that are double flanged that allow it to go up and down the track that help guide it. There is usually 3 motors on a typical crane. You have your bridge drive that allows the bridge to go back and forth, which means in this drawing up and down the length of the building. Then you also have your trolley drive that allows your trolley, which is a term for that assembly on top of the bridge, which moves left to right. And that allows you to go from, like, our building would be the north end to the south end. And that can move while the crane itself is moving the length of the building. So it's like a giant claw machine. You have maneuverability over the course of almost the entire structure, which made them very, very versatile and very valuable in moving material around. Then the other motor would be the hoist motor, which draws in the wire rope and allows the hook to rise and fall. Other features you see on this drawing are the pendant and the pendant festoon. That's how you control how the pendant cable goes in and out, because you really don't want that rope swinging down and getting in your way. Then, of course, you have bumpers on it, and you have rail stops on the rails to keep the crane from overshooting the end of the track. When you tear down an overhead crane, the typical practice is to take those runway barriers off, the rail blocks, and open up the side of the building, just pull the crane right out the edge of it, let it fall on the ground, and cut it up for junk metal at that point. Thankfully, most of the cranes inside the surviving buildings at Bethlehem Steel are still intact. And this is a good time to show just how many cranes there were. There were well over 1,000. This is a map showing the portion of the plant that the museum is in. We're in what they call the mechanical and electrical repair shop, which you see as the lowest building on this drawing. If you look up to the top, you'll see tool steel finishing department. That's the building that ArtsQuest has by the railroad tracks and Blast Furnace A, the westernmost blast furnace. You'll see the iron foundry. That building still survives today, but with none of its cranes. So on this drawing, each rectangular shape with an X in the middle is an overhead crane. They were really instrumental in making this place function. So you can see that there was just a mind-boggling amount of these things. Our building alone had 3 of them. There was one on the upper floor, which is still there today. It's a 5-ton capacity crane. But below that, on the first floor, there were actually 2 cranes. Only one of them survives to this day. The crane that we have is the crane that's in the far end of the shop. The crane that's gone is in the foreground. And we actually were able to go into our records and find the information on this crane. And I think it's a good point to note that the electrical shop is really a story in itself. Hopefully we'll be able to do a talk on that someday. We can see that they did the heavier work down below. They had lathes, racks for storing armatures. There were all sorts of other equipment used in the electrical repair field here. And then lighter work and storage was up top. So here's the crane book drawing for the crane that's long gone. You'll notice that they have big red X's on the drawing. That means there was no operator cage. It was always controlled from the ground level. This one was, interestingly enough, built by Bethlehem Steel, and it was a 3-ton capacity crane. And we'll zoom in. You can see some of the dimensions here. The building that we have is about 60 feet wide, so it has 59-foot, 2.5-inch span. And every crane in the plant had a logbook written up about this with the same details for it. And every crane had a number, so we can actually look up the number of a surviving crane in these books and learn more about its characteristics, or for that matter, cranes that are long gone too. So they didn't fill out a lot of the information for this crane, but for the crane that survives, which is our Pauling and Harshberger Crane, number 38, we do have a fairly complete data page on it. So we can actually zoom in here. It tells us a lot of fascinating details about the crane. We can look at the motors. They were made by Westinghouse. They're typical mill motors, 15 horsepower for the main hoist, 15 horsepower for the bridge. And then the trolley is only 7.5 horsepower. When it says weight per yard in the middle there, that refers to the weight of the railroad rail that the crane is supported by on those runway beams. 80 pounds mean the rail weighs 80 pounds per yard. So if you look at a typical mainline railroad today, that's lighter than what most trains run on, but you can still find branch lines with even lighter rail on them occasionally. One thing to note about the crane is that it has to interact with the building in some interesting ways. One of the things we found when we were designing the museum was the crane had to move from one end of the museum to the other before it was parked in place. And as we design our second floor, we have to make sure we account for moving the crane around because that one has some potential for being used in the future. So when you look at the architectural challenges of it, it's not just designing your building columns to be strong enough to support a crane, it's also how do you deal with other systems. So a lot of the electrical wiring had to be up in the ceiling or hidden up against the walls. And this unique feature was the downcomer. These take the drain water from the roof of the building and bring it down into the sewer system. But they were actually circular pipes. But because they were so large in diameter, the crane would actually hit them. So to design for this, they actually had these specially fabricated square boxes in the middle of the downcomer pipes that would allow them to thin out just enough for the crane to pass. So this is a view looking up, and you're seeing the bottom of the second floor there, but you're seeing how those downcomers pass. So it gives you some of the ideas of the challenges that you might not expect but have to deal with when you're working with overhead cranes. There is one other page we have that's relevant to the book. We'll go down to number 38 here. Here we are, Pauling and Harshberger Crane, 3317 is its serial number. And these two numbers on the right show the weight allowed per wheel on the bridge of the crane, which is 25,000 pounds. So theoretically, all four of those wheels added together up there could accommodate 100,000 pounds or 50 tons of load. So the crane is rated for 10 tons. We've been told that in maintenance lift where it's well supervised, it could be upgraded to probably double that capacity. So it's really fascinating to see how overbuilt these cranes actually were. 250 refers to the number of feet per minute the crane could travel. So it could do almost the entire length of our building in 1 minute, theoretically speaking. Well, actually, that's the bridge drive. So that's side to side. It doesn't have 250 feet of travel, but it's still a pretty remarkable speed that it's theoretically capable of. Here's a photograph from the mezzanine of the museum, which is a mechanical room today, looking down on the crane. So you can see the runway rail on the left. There'd be another one out of sight on the right. You can see the fish belly design. The stripes were painted on for safety purposes by Bethlehem Steel. You can see the trolley about a third of the way across, and you can see the four wheels that it rides on, the drive motor for it. And what you're not seeing here is off on the right. It's long gone now, but the crane being electrically powered by 250 volts DC had little trolley wires like you would see like a trolley going down the street in the major city. And those wires are how the electrical power got transferred to the crane. Some other cranes used rails, so they would have shoes contacting it, like the third rail on the New York City subway. And here's a close-up shot of some of the crane wheels. Because of the speed of the motors, which could be several hundred RPM at their peak, you would gear them down, and the gears were directly connected on this shaft, same shaft with the drive wheels of the crane, double flange, and these are a couple of crane wheels we have in storage at the museum. A lot of these you can still find at the Bethlehem Steel site. They were converted to bollards and separate the sidewalk between the roadways. So we can see here a view of the cab of the crane, which you can see very poorly in this image, but still there are the controls. There's three of them for moving the crane up and down the length of the building, bridge, that's the motion that they call it, trolley for side to side, and hook up and down. These are more modern controls. It probably had originally either like a drum controller that P&H was known for having. Drum controllers, which you see on, again, on old trolleys. they date to the same basic era, and it uses a variety of brass fingers on the inside to make contact with different points of resistance, which give you your different speeds for the crane. This was not a simple on-off device. He wanted to have as much control as possible over this thing. So you can see some of the electrical gear that's located up on top of the crane above the operator's cabin. There's also a lubrication reservoir, so you can actually pump this up, and there's lines that go to the various bearings. So that was a very nice feature that allowed them to lubricate this without going around to every individual bearing like you would have to do on some other machines. That was very time consuming, and then a crane could be very dangerous given the unusual location of these in very high places. Looking down, this is the drive shaft of the crane. We can actually put a wrench on this drive shaft and move the crane by hand. That's how easily it turns. And that's why you only need a 15 horsepower motor to move not just the crane, but its entire load, which was rated at 10 tons. This is one of those typical mill motors. You can see that it's actually hinged, so you can open it up, get inside of it to do maintenance work. It goes to an enclosed gear drive that operates other features on the trolley. So you have your motor that drives the trolley back and forth, your hoist. And you can see our hoist has, I think, 5 wire ropes going down to it to amplify the force that you're picking up. Then you also see on the right is the crane brake. We're going to enter a presentation in a moment talking about that. But before we do, this is a good point to show how the power actually got to the trolley up there. There's 1, 2, 3, 4 cables on the left-hand side of the picture, and these little contacts that would actually take power from those, transfer it to the trolley. That way, even though the trolley is moving back and forth, you're still getting electrical power delivered to it the entire time. What's also interesting about this is even though it was built in Milwaukee by Pauling and Harshberger, they got their steel from Lackawanna before it was purchased by Bethlehem Steel, which later became their Lackawanna plant. So there's always these fascinating connections that tie all of these sites together. So there's a lot of technical things we can go into with cranes and the Bethlehem plant, but I think this gives you a general overview of how our crane worked. And as we put the brakes on the presentation, I'll end it with a discussion of the brake on the crane. This is really a fascinating feature about it. You can see that there's a spring in there, and there's 2 shoes that grip the brake wheel. The spring normally forces those shoes against the wheel so it stays tightly closed and the crane is immobilized. Then the operator, when he energizes the controls, uses an electromagnet on the right-hand side to work against that spring to pull those shoes off. And then he can freely operate the crane, whatever motion he needs to make. But if there's any sort of problem or he wants to hold the load or they lose power, then the electromagnet automatically turns off. The spring forces those shoes against the brake, and that keeps the crane held still. And that system is still in place today. When we had to move the crane, we had to immobilize it by using a bar to pry the brakes apart as we move the crane. But as soon as we were done, it sprung right back into place. And then the crane wheels were also blocked up, so it's been immobilized. But it's still a complete crane, except for the incoming power source along the building run. Everything else is there. So I think this is a good time to ask for any questions. And hopefully you guys learned some more about an artifact that we all pass through at the museum, but we might not have the chance to really explore because it's overhead.
Thanks so much, Mike. Let me see if there's any questions here. Hi to Claire, Dan, Christine, Tracy, Amber, if you guys are all still watching. You might have touched on it at one point, but I'm not sure. Was the crane original in the building? Was the crane installed when the building was built?
We don't have a firm record on that, but we have no reason to believe otherwise.
Okay. And I think you had touched on this at one point, but I don't remember the answer. Kathy had asked approximately how many cranes were in the Bethlehem plant.
We're guessing well over 1,000 based on the crane numbers we've seen. I can't say that they were all in service at the same time, but when we look at those drawings, I have what I showed there in that little snippet. I can go back to it. This is a good point to talk about in the question. This is just the equivalent of 1, 2, 3, 4, 5, maybe a 5 or 6 block area of the plant. the New Street area where the Riverport is today. That doesn't even show on this drawing. The blast furnaces don't show on this drawing. So this is one fraction of the plan that you already got. Well, I need to count it here. You guys can write it up on the screen here. But when there were hundreds, or as the numbers seem to indicate, 1,000 cranes, it's very, very believable.
Yeah, one of the numbers there is like 449, so that's at least 450 that you know of.
Yeah, we could go at some point and actually go through all of our records and count them, because we do have a very good record of number of cranes.
I don't think we have any other questions, but would you be able to talk about the other two talks that are coming up, the Phillipsburg engine and the tug briefly?
Yes, our friends at the New Jersey Transportation Heritage Center have the largest operable steam engine in the country, half an hour from the museum. So it's a place we love to visit and check in on. So they're actually going to be doing a talk on that engine, which was built by Alice Chalmers, which was located across the street from Pauling and Harshberger. And their crane problem gave Pauling and Harshberger the idea to get into the overhead crane business. So we thought that would be a good time to tie in with that Made in Milwaukee theme. So they're going to be doing a virtual tour of their facility, which will take you from the very lowest point of the engines, where the water comes in, all the way up to the top and even above the boilers, to really give you a first-hand look at a fascinating piece of machinery. And as you watch that, pay attention to their overhead crane. They have one in their building because, again, these are critical pieces of infrastructure, but pay attention to how it's powered. I think you'll find that very fascinating. And then we also have, after that, coming up, a new type of talk. It's a walk around we filmed with one of our volunteers, Gary Gum, and he's doing a walk around of our tug, which is an airport pushback tractor Bethlehem Steel used as a locomotive inside buildings, to move railroad cars around street level trackage, and also to pull a mill buggy around inside the combo mill, which is where they made wide flange beams, piling, and other products from the late 1960s to the late 1990s. So I hope you guys will enjoy those talks, and we'll look forward to seeing you again soon.
One more question just popped in. John had asked, what was the source of the DC power for the crane, and how is the motor speed controlled?
So the source of the DC power, there's actually an excellent article by Tom Blaylock that was published, it must have been a decade ago or more, that goes into detail on this. But the long and short of it is Bethlehem Steel had their own powerhouse. Right before World War I, they started making AC power, so that would have been converted by motor generator sets to DC. And they also had their own DC generators too. So the power was, and they also had power that came in commercially from Hotto generating station, from PPN, well, I think PPNL, I'll have to double check that. But bottom line is they had their internal and external power sources, and they had converters. And some of the cranes that are in successor facilities to Bethlehem Steel are still being powered by DC, probably to this very day, using rectifiers instead of motor generator sets. And then the control system worked basically the same way it did on trolley cars. You have a controller with, I don't have a picture handy of it, unfortunately, but you have a knob that revolves a central shaft, and then off of that shaft, there's different brass fingers that contact different points connected to resistor banks that are located on the crane or whatever type of electrical equipment you're running. And as you want to accelerate, you move from resistance bank to resistance bank, you gradually decreasing the amount of resistance to increase the amount of power going to the motors, and that's how you control it. The same technology is used on the diesel electric locomotive in the museum's front yard. So that's a good place to see it in ground level in person. So we could probably do a more detailed deep dive into electrical controls, because that's really a fascinating topic. And of course, how they were upgraded over the years too. So hopefully that gives you enough of an answer to get a start on it.
Excellent. Thanks everybody out there that joined us. I think that was the last question that we had. Again, stay tuned to our Facebook page and our website at NMIH.org. Later tonight, actually, we're premiering a new series of videos called Innovation Station. We're going to be talking about how different household products were created and how they became, household products, and how they're made and kind of the story behind them. and that's featuring our curator of collections, Andrea Zaya, and her assistant, Emily Marcello. So we're very excited to have that. So stay tuned for that later tonight. And again, we have all kinds of talks coming up. Mike just touched on some of them, and they'll be posted here on our Facebook page and on our website at NMIH.org. And if you have kids out there, we're going to be doing a virtual summer camp this year. So if you're looking for something to do this summer, and instead of just staying at home looking at an iPad, we're going to have a really cool interactive program where kids can talk to advanced manufacturers, including Martin Guitar, B. Braun, Stanley Black & Decker, and more through our virtual summer camp. So all that information you can get at the link that's in the comments below, or you can head to our website at NMIH.org. And thanks again to Mike for joining us and providing a great little insight to a very important artifact in the museum.
Thank you for having me.
Afternoon, everyone.